Hi friends, in this video I am going to show you one more application of this 595 shift register IC to create this smoothly moving LED effect using the concept of bit shifting and PWM technique. And note that I am going to use software PWM in this video, not hardware PWM. So let's get started. Before stepping further, I want to make an important clarification here regarding this IC. So see, we generally connect only 3 pins of this IC to the Arduino or any other microcontroller, and those 3 pins are data pin, clock pin and the latch pin. So what most of the people think that if we are implementing software PWM, then we must connect the data pin of the IC to the PWM supported pin. But actually it's not the case. Although I connected the data pin of the IC to the pin number 9, which is PWM supported, but if you connect to any other normal digital pin which is not PWM supported, it will also work. PWM supported pin is only used when you are using analog write function, and that is the case of hardware PWM. But we are using software PWM, so it is not needed. So this is one of the confusions that we generally have regarding this IC. Now I would recommend you to watch this video to know the complete working of the shift register IC, and in this video I use the GUI to explain the internal working of the IC. Now in the program we are defining all the 3 pins, data pin, clock pin and the latch pin. And these are the scanner variables position and direction. Position means which LED and direction means whether we are moving left or right. And these are the brightness level of all the LEDs to create the trail effect. And this is the frame per step is equal to 16, right? And I will explain you what is this frame. And in the setup function, all the pins are going to be in the output mode. Now here comes the core part of our program, which is the loop function. And in this function, we are calculating the new frame. So frame is basically one complete visual state of all the LEDs at a particular moment. So this is like capturing the photo of all the LEDs at a particular time. Okay, so that photo will be representing one frame. And in this for loop, we are fading up all the LEDs to create the trailing effect. Right? We are using the right shift operator, which is nothing but dividing by the value of 4. So by dividing by the value 4, we will decrease the brightness of all the LEDs. And if the brightness of a particular LED is less than 15, then we will turn off that LED. It means brightness will be 0. Now before rendering the frame, we are setting the brightness of a particular LED is equal to 255. And in this for loop, we are running the PWM values from 0 to 255, which is the maximum value of the brightness. Now this output variable is basically representing that which group of LEDs should be on at a particular time. Okay. Now let me explain this for loop, why we are using a OR operation here. So suppose you want a combination of these bits 0 0 1 0 1 1 0 0. Okay, for I is equal to 2, we will shift the 1 bit by 2 position. So 1 will be sitting here initially at this position, shifted by 2 position 1 2. Similarly for I is equal to 3, 1 will be sitting here. For I is equal to 5, 1 will be sitting here. Okay. Now if you take the OR operation of all these 3 combinations, you will get this 0 0 1 0 1 1 0 0. That is why we are taking the OR operation here. Okay, this is the OR operation. And we are sending this output variable on the shift register using this function, send to shift register. And this is the point number 3, move scanner for the next loop iteration. And if the position is greater than or equal to 7, it means we have reached the end of the LEDs. Then we will reverse the direction by -1. Similarly, this else if condition. And finally, we are sending the data to the shift register IC. So if you enjoyed this video, don't forget to subscribe to my channel and share this video. And if you want me to upgrade something in this project, leave your thoughts in the comment section. And we will meet with the new project in new video. And thanks for watching.